Hi, I'm Mark Samer. I'm president of Dragon Slayer Consulting. I'm here with VR Satish of Pavilion Data. VR, thanks for coming.
Always a pleasure to talk to you, Mark.
VR, I have a question for you that has to do with storage density, actually. And storage density, most people refer to that as capacity. Think about the capacity in a small space. But I also hear about storage performance density. What's the difference?
So, to understand that, let's define what density really means in terms of physics. Density is, mass over volume. In data center speak, volume is represented by the number of rack units that you use. They call it either RU or just U, or however you want to call it. Number of rack units. Now, capacity density is all about how much capacity can you put into a single RU, right? So how much terabytes? It's terabytes over RU. Now, when you look at performance density, it's how much performance can you get out of a single RU, right? Now, this could be, performance is measured in our speak using IOPS per second, with a fixed size block, either 4K or 8K. Or you could look at, bandwidth or throughput coming out of a single RU, depending on the application that you want. Now, at the same time, you want a balance between performance density, as well as capacity density, which you want to club it together as performance density, which is not only how much capacity can you pack inside a single RU, how much performance can you generate on top of that from that single RU. That's an engineering marvel.
Can't you just increase the storage performance density by adding some solid-state drives?
You can. You actually can. Actually, the more the number of spindles, we all know in the storage world, the more the number of spindles, you can actually stripe over it and get better performance. But you have to look at it this way. You are dealing with a constrained amount of space. And when you want to add something to it, you have to take something out because it's already packed, airflow, cooling, and you got to look at all that stuff. So it's like playing whack-a-mole. So you can add more capacity, but you may have to remove a CPU out of the stuff. At which point what happens, you give up on performance, but you get more capacity density. Or if you want more performance, you add more and more CPUs, and then your capacity starts going down. Right? It's a very delicate balance that we have to play. So it is, like I said, it's an engineering marvel to keep all this in. Let me give you an example. Anybody can do a fast computer.
Fair.
Everybody makes it. You get tons of people doing this. I could build my own if I wanted to. But building a fast computer in the form factor of a phone, which fits in your pocket, man, that is tough.
So tell me why storage performance density is important. What problems does it solve for the users?
So at the end of the day, there's an old adage which we always use, less is more, right? So, the lesser of anything that you have, the lesser clutter it creates, right? If you have, lots and lots of, equipment, because you couldn't fit so much into a small form factor, and let's say you use 4 racks for what you could do in 2U, right? There's just more space it occupies. There's more energy that it consumes. There's just more cabling. There's more infrastructure. There's more people you need to manage this stuff. It's operational nightmare at the end of the day. And all this may not be very evident when you're just talking about 2 to 3 racks. But you look at people, some of these hyperscalers, they are talking about massive data centers, going sprawling across all, and they have thousands of racks. And at that point, it makes a big difference on storage performance density. It makes a huge difference. And why performance density is important? Data is growing. When you have data that is growing, not only do you need to store all the data, you need to analyze all the data in near real time.
And I've heard from talking to lots of data center facility managers that their biggest problem is how they get enough power and cooling into their data center for all this big data. Does this reduce that? Does storage performance density have an impact on that?
Absolutely. Look, at the end of the day, it all depends on the components, right? You can make it much more denser, but if you're going to increase the power profile, then you're out of the game again. So at the end of the day, I heard this I read this recently.
ICT, I believe.
ICT, okay. And they were saying by 2025, 20% of all energy consumed by everything on the earth is going to be used for IT. That is a really scary proposition. And that's, by the way, IT, more greenhouse gases, global warming, and all that stuff happens, So it's imperative that, to maintain cost, to reduce complexity, to do good for the planet, we need to miniaturize this stuff, consume less energy, use less floor space, and, process more data at the same time, and keep more data.
Well, that brings me to my last question. How do you solve this storage performance density?
That has been our biggest challenge. With all the noise coming across with, I can pack in a petabyte in a 1U or half a U, ruler form factor and all that stuff. It's great innovation. Let me not downplay any of that stuff. Our biggest challenge was capacity is one thing. How do I use that capacity in a performant way? So we actually designed a system with up to 20 processors, 20 controllers, looking at a great 1 petabyte capacity, all in a small 4U form factor, while our competitors are still, looking at giving the equivalent performance and the equivalent capacity in 4 racks. That's an engineering marvel. We are essentially building what Apple did to phones, or Apple did to computers. We're trying to do it for storage. That's where we come.
Well, thank you, VR. I appreciate the update.
Thank you very much.